Hey everyone, welcome back to the HTML5 Canvas for Beginners series. Now in the last episode, we learned how to work with images on the canvas, where we drew characters on the screen, cropped and scaled images, and also set background images on the canvas. And today, we are going to be working with animations. Animations are what make your projects feel alive, whether you're building games, interactive visuals, or cool background effects and animations like this. Animations have you covered. In this episode, we'll be covering smooth movement, bouncing shapes like this, rotations, and even dynamic resizing, as you can see on the screen, how this square is rotating and growing and shrinking in size. Well, by the end of this video, you'll have the foundation to bring your canvas creations to life. So, without further ado, let's get on with the video. Okay, to start, we are once again inside our Coden's own compiler with index.html, a canvas tag with the ID myCanvas. I have styled it to have a border so that the canvas is visible to you guys, and a script.js where we have selected our canvas and gotten the 2D rendering context as well inside CTX. Now, let's start with the core idea about what an animation is. An animation is just a sequence of frames being drawn over and over again, and inside the canvas too, we'll be doing just that. First, let's write a function which will draw a red square on our canvas, and later we can go about animating it. So first, let's define where the square will be drawn. So its coordinates, let x equals 50, and then let y equals 50 as well. Now we'll create a function called Animate, and inside our function, first let's select a fill style for our square. So fill style equals red, and then let's actually draw our square with a fillRect method. So fillRect, and then inside the coordinates will be x and y, and the width will be 50 and the height will be 50 as well, so in order to actually draw the square. Now we'll call this function Animate, and we can see that a red square is drawn at the position of 50 and 50. Now after drawing our square onto our canvas, let's make it move continuously with the passing of time. And in order to move something on the canvas, we need to change the value of its coordinates, namely its x and y coordinate or both. So first we will create a variable to determine how much we want to move the rectangle or the square in each frame of our animation, and we'll be moving it horizontally at first. So let's define a variable to determine how much it will move. So let's speed x equals 2, and after that, inside we will increment the value of our x position each frame with the help of speed x. So if we run this function, animate function, over and over again each frame along with the passing of time, the value of our x coordinate will go on increasing by 2, and consequently the square will go on moving towards the right since the x value will be increasing. Now in order to actually draw, or let's say use this function over and over again with each frame, we'll use a method called requestAnimationFrame, and this will take an argument of a function which will be Animate. So you can see that our square is actually moving to the right, but it is leaving behind a trail of its previous drawings. And that is because we actually haven't cleared the canvas before we draw each square on the next frame, and which is moving towards the right. Okay, let's first comment this, and in order to fix that issue, we'll be using a method called ctx.clearRect. Now what this will do is it will clear our canvas to the area that we define. So if we start from 0, 0, that is the starting point of our canvas, and if we want to clear the whole area of our canvas, we'll have to enter the canvas's width and the canvas's height. Now if we uncomment our animation, or let's say requestAnimationFrame, what will happen is it will clear the previous position of our square, and since the position of our square is updating in each frame, it is moving right by 2 pixels in each frame, it will look like our square is moving. So what will happen is it will look like it is moving with each frame. And that is how you animate inside Canvas. Now you might have gotten an idea about what requestAnimationFrame actually does. This method tells the browser to run a specific function, in our case it is animate, which draws our rectangle or square onto our canvas right before the next frame is drawn on the screen. So this is how we create smooth animations, by updating and drawing a tiny bit each frame. This gives us smooth and consistent motion, typically about 60 frames per second. And it is also smart, so it pauses automatically when your tab isn't visible, so it saves CPU and battery as well. So every time that the function animate runs, the shape shifts a little, which creates continuous motion like this. So as of right now, the exposition of the square goes on increasing and the square goes off bounds. So let's make it bounce on the left and right wall as it hits the walls. And for that we have to add a condition inside our function. So after x plus equals to speed x, let's add an if condition. If x plus 50, which is the width of our square. Okay, let's first, this is quite distracting, so let's first stop it from moving. And if x coordinate, so our x coordinate of the rectangle, so let's say the starting position of our rectangle plus 50, which is its width, is more than or equal to the width of the canvas, that is this width right here, this point is representing this point. So if it is more than or equal to the canvas's width, or if the x coordinate is less than or equal to 0, that is this edge right here, the left edge, will make it so that the direction of speed x is reversed. And to do that we have to do speed x equals minus speed x. Okay, let's see what happens when we uncomment this. Okay, right now the square is going right. Okay, it bounces off the right wall and it bounces off the left wall as well, and that is all because of this condition and this line as well. This way, if the rectangle touches the edges of the canvas, the direction is reversed, and that gives us the illusion that the square is bouncing. And now that we know about the basic knowledge behind animation inside Canvas, let's level up and make something more dynamic. A ball that moves around and bounces when it hits the edges of the canvas. And this time, we won't just move it in the x direction, we will move it diagonally. That is, we'll change both the x and y values. And for that, let's first delete all of this. Create x and y, we'll place this at 50-50. And let's say we'll create a let dx, this will be the horizontal speed, and let dy, which will be the vertical speed, so it will be 2. After that we have to define a radius variable for our ball, which is in fact a circle, so 30. And after that we'll create a new function called function animate ball. Now inside this we will first of all use clearRect so that the ball doesn't leave a trail behind, and this will be canvas. Okay, I should have put a comma canvas dot width, and then canvas dot height. Now after this we will actually draw the ball. So to draw our ball, if you remember, we have to do ctx.beginPath to tell canvas that we are going to draw a new shape, and then use the ctx.arc method, which takes the coordinates of the center, which are our x and y values, and then after that our radius as well. So radius, our starting angle, and our ending angle, which is in radians, so we will use math.pi times 2, which is actually 360 degrees, and this will draw a ball. Now we'll use a fill style of orange, so let's say our ball will be of an orange color, and after that we'll use ctx.fill. This will actually create the ball, and after that let's close the path, so ctx.close path. Okay, before we start our animation, let's see if the ball is being drawn or not. So animate ball. Okay, I see what I did. I should have put a comma here, my bad. Okay, we have drawn our ball right here. Now in order to actually animate it, we have to first of all write the logic to update its position at each frame. So update position, and this will be x plus equals to dx, and then as for our y position of our center, we'll do y plus equals to dy. And after that, we'll write a logic for bouncing off the walls. So for that, we will first write if x plus the radius is more than or equal to the canvas width, or the x minus radius value is less than or equal to 0, what we will do is we will reverse its direction. So dx equals minus dx. And kind of the same logic with the y value, but instead of width, we'll place it as height. So canvas dot height, and this will be y, and then this will be y as well, and also our dy value will be changed, so dy. Now all that is left is to call this function again and again with the help of requestAnimationFrame. So requestAnimationFrame, and we'll call our animate ball function. So we can see that our ball bounces when it hits the edges of the canvas, and that is because of this logic right here. And the reason that we wrote plus radius is because the coordinates of x and y is that of the center of the circle, not of the edges of the circle at all. So if we, for whatever reason, miss out on radius, we'll be able to see that the circle first goes half inside of the right edge, and as soon as it hits the center, it bounces back. So in order to accurately depict the bouncing ball, we'll have to add the radius value. So it will be radius. So we can see that it bounces off accurately. Okay, so that was how you move and bounce a ball around inside your canvas window. Now animations aren't just about moving things around. We can also rotate and scale our shapes dynamically. And for that, I'll have to first of all comment all of this out, or let's say remove all of the code for this. And we'll have to create an angle. So let angle equals 0. For rotation, we'll be using this value right here. And we'll create a new function called animate rotation. And inside this, we'll of course first use the clearRect value, since this is important for animation, 0, 0, and then canvas.width and canvas.height. Now after this, I should have placed this with no space. Okay. Now after this, we'll write a ctx.save, and this is to save our game state and prevent other things from rotating inside our canvas. Now after we do this, we'll have to use a special method called ctx.translate. Now in this, x and y values are entered, so canvas.width by 2 and canvas.height by 2. Now what we have done is with ctx.translate, we have shifted the center of our origin to the center of the canvas. So normally our points would start from 0, 0, which is the top left corner of our canvas. But with this, we have placed our origin at the dead center of our screen. And we will see how this will affect our rotation later on in the video. Now, after this line, we'll have to use ctx.rotate. Inside our parentheses, we'll type out angle. And after this, we'll first create a rectangle or a square. So let's create a square at first. ctx.fillStyle, which will equal to, let's say our square is purple. And then we'll use ctx.fillRect and then -50, and then 100, 100. So the reason we have done -50 and -50 is to place our square at the dead center. If we hadn't done this and we had just done 0, 0, it would start from here. But if we do -50 and -50, it will start from right over here and it will be placed at the center of our canvas with the width 100 and 100. Now after fill rect, what we will do is we will use ctx.restore at first. So let's see if our square is formed when we call the function. So animate rotation, and you can see that our square is at the middle of the canvas. Now in order to actually rotate this, we will have to increase its angle at the end of each drawing. So we'll have to do angle plus equals to 0.05, let's say. Now this is to control the rotation speed. And after that, of course, our final step is to use requestAnimationFrame to call this function again and again. So you can see that our square has started rotating. And that is because we rotate our square by a certain angle during each frame, and that angle keeps on increasing, so it keeps on rotating and rotating. And the reason that we used translate was because if we had done this, our square would be spinning around over there. So how ctx.rotate works is it makes the objects inside our canvas rotate around a certain point, and by default that certain point is the origin, that is 0, 0. Now if we had done this 50 and then 50, you can see that the rectangle, or let's say the square, is not rotating on its own axis, but it is rotating around this center, which we have set using ctx.translate. And if we hadn't done this as well, it would be rotating around this origin point right here. You can see that it's going round and round around this point. And to make the square rotate on its own axis, first we have set the axis to be the center of the canvas, and we have positioned the square in such a way that its center is on the axis as well. So the square center is the axis of the canvas, so that is why it is rotating around its center. And I hope that is clear to you guys. And not just using rotations inside animation, you can also use the ctx.scale property to scale the width and height of your objects equally. And for that, of course, I have to define a few variables. One is scale and one is a boolean, which we have used to either grow or shrink the size of this object, or let's say the rectangle right here. And I have used it inside the if-else condition. If growing will increase its scale, and if it exceeds a certain scale, we'll turn growing to false, and that will make it decrease the scale value. So I'll not explain this code or type it out in detail since this video is getting too long anyways. So I do encourage you guys to try out this ctx.scale property along with the ctx.rotate property. And as always, I'll be leaving a source code of this down in the description below. You can check it out if you want to just take a look at the code, or if you want to look for your mistakes as well. And that was it for this video. You just learned how to bring your canvas to life through animations by clearing frames, moving shapes here and there, bouncing effects, and smooth rotations and scaling like this. These are the core building blocks for everything from games to interactive UI animations. And in the next episode, we'll make our canvas interactive by making it respond to mouse clicks and keyboard inputs as well. It is going to be a fun one, so don't forget to like, subscribe, and ring that bell so you don't miss it. And until the next time, bye bye and happy coding.